Hello everyone. Now we have to discuss the variation in wattmeter readings due to what power factor, right? We have done the analysis of last class with respect to lagging power factor, right? The wattmeter reading 1 and we have wattmeter reading 2, that is VLIL cos 30 plus 5, like that VLIL cos 30 minus 5 is due to what? The analysis based on lagging power factor, right? So where phi is what? Power factor angle. So by changing that angle we can change the wattmeter readings, right? So we can write that point here. We have seen that for a lagging power factor, load, okay, wattmeter reading 1 is nothing but what? VLIL cos 30 plus 5, right? And wattmeter reading 2, that is VLIL cos 30 minus 5, where phi is what? Where phi is what? Power factor angle or angle between VL and IL, okay. In this case it is VLIL, okay. Then we have to means what? Thus the wattmeter readings vary not only on the load but the wattmeter readings also depends upon power factor. This is very important observation from this. That's why we can have the title what? Variation of wattmeter readings due to power factor. Thus the wattmeter readings vary not only on load but they vary on power factor 2, okay. So the wattmeter readings are totally depends upon load as well as power factor, that is in simple words, the wattmeter readings or depends on load and power factor. That's it, okay. Now we have to vary this angle, okay. We have to vary this angle phi from 0 to 90, right? Now we can observe what are the wattmeter readings, okay, with the different cases. First here I am considering case 1. Let us consider the case 1 as, first case, phi is equals to 0 degrees, okay. Phi is equals to 0 degrees. We all know that. What is the power factor for this case? Power factor which is equals to unity, clear. Then load is what? Load is pure resistive load. That's it. Then what about wattmeter readings, which is equals to what? Phi is equals to 0, therefore VLIL we have cos 30 which is equals to what? 0.866 VLIL, like that. Wattmeter reading 2 is what? VLIL cos 30 which is equals to what? 0.866 VL/IL. So from this we can say that we have equal wattmeter readings when phi is equal to 0, means when the power factor is unity we have equal wattmeter readings. We have equal wattmeter readings. Hence both the meters will read positive and equal readings. So in this case, when phi is equal to 0, we have which is equals to, these observations are very important for your Genco, Transco, NPDCL, SPDCL. Okay, these are very important. That's it. This is case 1. Now case 2. Case 2, here I am considering case 2. For case 2, the angle is increases to what? Let us say 30 degrees. Okay, if it is 30 degrees, obviously the load is what? Lagging load, right? It is not pure resistive load. Therefore, we can write wattmeter readings what? Wattmeter reading 1, which is equals to VL/IL VL/IL cos 30 plus phi. So from this we have cos 60, right? So VL/IL by 2, VL/IL by 2, like that, is equals to VL/IL cos 30 minus 30. We have cos 0, which is equals to what? VL/IL. That's it, right? So from this we can say that the wattmeter reading of 2, which is more than wattmeter reading 1. This is second observation, right? So next, and in this case, what is the power factor? Forgot to write. Power factor is what? Which is equals to 0.866 lag, right? Because the load is lagging load. This is for phi is equals to 30. Next, case 3. For case 3, here I am considering phi as 60 degrees. Therefore, for phi is equal to 60 degrees, power factor is what? Equals to 0.5 lag, right? Power factor is 0.5 lag. And what about wattmeter readings? Which is equals to VL/IL cos 30 plus 60, that is cos 90, which is equals to 0 watts. Like that, wattmeter reading 2, VL/IL cos 30 minus 60, cos of minus 30. Again, cos of minus angle is equals to positive only. That is, we have what? 0.866 VL/IL. So in this case, when it is 30 degrees as well as 60 degrees, but see here we have wattmeter reading 1 is nothing but half of the, sorry, here forgot to write the important point. In this case, wattmeter reading, which is wattmeter reading, wattmeter 2 reading, which is equals to 2 times of, or you can write forgot here. This is very most important point. Yeah, omega t is more than omega 1. Sorry, Wt is more than W1. But what is the relation? W2 is equals to 2 times of W1. Okay. This is very, very important observation. See, Wt is what? VLIL. W1 is what? VLIL by 2. This is the relation, right? So from this case 3, phi is equal to 60 degrees. W1 is what? 0 watts. Wt is what? So W2 is more than W1. And one more important observation. What is that? We have 0 and we have positive here. Both are positive. Okay, this is the observation. Okay, this is wattmeter 1 reads 0 and wattmeter 2 reads positive value. Okay, so these 4 cases are very most important. Okay, 0 degrees, 30 degrees, 60 degrees and finally 90 degrees. Case 4. What is case 4? Maximum value is what? Phi only. Phi is equals to 90 degrees only, right? So in this case, what is the power factor first? Cos 90, 0. Power factor is equals to 0 lag, which is equals to, you can say 0 lagging, right? Then what about the wattmeter readings? Wattmeter reading 1, VLIL cos of 30 plus 90, cos 120, which is equals to what? Minus VLIL by 2, right? Like that, wattmeter 2 reading is what? VLIL cos of 30 minus 90, cos of minus 60, which is equals to what? Positive value, VLIL by 2. See, here wattmeter 1 shows negative value, wattmeter 2 shows positive value, right? So under this condition, wattmeter 1 reads negative value. So to obtain the value of wattmeter 1, it is necessary to change the terminals of either pressure coil, that is potential coil, or current coil. This is very, very important observation. So here wattmeter 2 shows what? Positive value, but coming to wattmeter 1, it shows negative value. So in order to get wattmeter 1 as positive value, we have to interchange the current coil or potential coil. Either one terminal should be changed, not both. Okay, we can write that point. Under this condition, would read wattmeter 1 would read negative value. To obtain a reading on wattmeter 1, it is necessary to interchange. It is necessary to interchange the terminals of either the potential coil or current coil, but not both. If you change both the terminals, obviously it is same as like previous case. So this is very, very important point. This point will helps you while you performing the practical sessions in machines lab, okay, or measurements lab. Okay, this point is very important. If you have negative wattmeter reading, obviously what you have to do, you have to interchange the terminals of either potential coil as or current coil, that's it, but not both. Okay, so the readings taken after reversal of pressure coil are to be taken as negative. Okay, it may be noted that we can write in a fresh page. See, the point is, what is the case 3? See, in case 3 we have one wattmeter reading as what it shows 0 watts. So in case of 90 degrees it shows negative value. So means what? One of the wattmeter among two wattmeters shows negative value after phi is equals to 60 degrees. Means if phi is equals to 60 to 90, obviously it shows one of the wattmeter shows negative value. That is the point here. It may be noted that for phi is equals to 90 degrees, wattmeter 2 shows what? Negative value of, right? This is the relation between wattmeter 2 and wattmeter 1 in case of 90 degrees. Omega, so W2 is equals to minus W1. That is, the summation of this two wattmeter should be equals to 0. That is, there is no real power. Means what? No real power, because power factor is what? Since power factor is 0. Okay, see, from this we can say there is no real power. Based on power factor also we can say, because power factor is 0, there is no real power. Okay, for angle 60 degrees should be present between 90 degrees. If the angle is present between 60 to 90, we are having negative value of 1 wattmeter, right? So in this case will be positive, omega 1 will be negative. That's it. If we have negative value of wattmeter reading, just we have to interchange the either pressure coil terminal or current coil terminal, but not both. This is the analysis of variation of wattmeter readings due to power factor. Okay, so these are the equations W1 W2. Based upon this different phi, we have different cases. These 4 cases are very most important cases. That's it.